Hello, and welcome to our presentation, Running Your Own Large Language Model Using Ollama and AWS. First, I'd like to introduce ourselves. I'm Joseph Arias, and our team consisted of Jeffrey Tam, Edward Salame, Jason Bang, and Brian Chica.
This is our presentation agenda, which we'll cover in the following slides. This project will encompass the development of our own self-hosted AI that can be customized for any business. We will deploy our own custom large language model, LLM, and deploy on an AWS EC2 instance within a Docker container to host Ollama. We will run different models within that host like DeepseekR R1 and Llama3.2. Running it through AWS will allow us to remotely access our own cloud-hosted LLM wherever we please. To complete this project, we relied on 5 key services. First, we used Llama as a platform to run our large language models. The second service, DeepseekR R1, is a newly released LLM that's similar in functionality to popular models like ChatGPT. The third service, Llama3.2, is another powerful LLM that we included in our testing process. The fourth service is Amazon Web Service, AWS. We used AWS to launch an EC2 instance which serves as our cloud environment to host Ollama. And finally, the fifth service is Docker. Within the EC2 instance, we use Docker to create isolated containers, making deployment and management of the models more efficient. Together, these 5 services form the backbone of our infrastructure and make this project possible. Let's start with the basics. What is an LLM? LLM stands for Large Language Model. In simple terms, it's a type of artificial intelligence that can understand and generate human language. These models are trained on massive amounts of text data from the internet, books, and other sources to learn how language works. The more data it's trained on and the more parameters it has, the better it performs. In our project, we're working with 2 open source LLMs. Llama3.2, developed by Meta, which is known for its high performance and cutting edge architecture, and DeepseekR1, a newly launched model that functions similarly to ChatGPT and is optimized for various language tasks. These models are run using a platform called Ollama within a Docker container using an AWS EC2 instance, which will allow these models to be accessible anywhere and not just from a single machine.
So now we're going to talk about what is Docker and why we should use it. Docker is a platform that allows us to package applications and their dependencies into containers, which can run applications across different environments. For our project, Docker made it possible to run the Llama language model without having to worry about infrastructure considerations. By containerizing the model, we ensured fast deployment and easy collaboration and resource management. Docker makes for an ideal environment to test applications because the applications themselves are hosted in an environment isolated from the host operating system and can be modified without interfering with the host's day-to-day operations. One of the last but most important services we use is AWS. So what is AWS and why should we use it? Amazon Web Services, or AWS, is a cloud platform that gives us access to scalable computing power, storage, and networking resources. For this project, AWS played a crucial role by allowing us to host our own large language model inside a Docker container on a virtual machine, specifically an EC2 instance, which is Amazon's virtual machine service. A key advantage of AWS is its easy integration with containerized workloads on an EC2. Besides these benefits, AWS offers a high availability through its global infrastructure, with multiple server regions and availability zones. That means if one server fails, another can take over without any disruption. This is critical when running high-performance workloads like LLMs. Overall, AWS gives us flexibility, scalability, and security, which is everything we needed to experiment and deploy our own LLM in the cloud. So what are the benefits and why would a business consider running their own large language model as opposed to just using an API like ChatGPT? The first benefit is data privacy. When companies use external APIs, their data is sent to third parties. With an in-house model, your data stays under your control. This is ideal for sensitive fields like healthcare, law, finance, or just any organization with sensitive proprietary data. A second benefit of using self-hosted LLMs is the ability to tailor it to the needs of your business or industry. For instance, LLM tools such as code reviewing can boost productivity for programmers in the workplace. Or maybe you work at a law firm and would like to quickly summarize the knowledge base of cases your firm has worked on. Maybe you work in a medical office and would like to schedule appointments while seamlessly incorporating patient history. The flexibility of self-hosted LLMs can create intelligent, customized solutions that boost efficiency, enhance decision-making, and help your business stay ahead in a competitive landscape.
Good morning, class. My name is Brian Chica. In this section, we're going to stand up our very own mini ChatGPT by running Meta's Llama3.2 1 billion parameter model inside Docker on a single GPU powered EC2 instance. First, let me quickly show you the AWS services we'll lean on, which will be compute, storage, networking, security, and I'll dive into them a little further in the next slide. We're going to split the work into 2 containers, a backend container running llama.cpp via Ollama. This engine loads the 1 billion parameter model and exposes an OpenAI compatible REST API. Think of it as the engine that powers the AI, which is used for running and managing LLMs. Second is the front-end container running OpenWebUI. It provides a ChatGPT style browser interface that connects to our Ollama API. We wrap both in the single Docker compose file so they start in the right order, share volumes, and know how to talk to each other. Next slide, we'll dive into exactly which EC2 specs, storage size, and networking rules make all this run smoothly. Picking the right EC2 instance is key to bouncy performance and cost when running. We chose the G4DN.X Large, which offers 4 virtual CPUs, 16 gigabytes of RAM, and NVIDIA T4 GPU with 16 gigabytes of virtual RAM. This is enough muscle to load and serve our model and runs at about 52 cents per hour on demand. The image we will use is the AWS Deep Learning AMI, or known as Llama, an Ubuntu image preloaded with NVIDIA drivers and CUDA, so GPU support works out of the box, no extra setup required. For storage, we attach a 75 gigabytes of EVS, plenty for the OS, Docker images, and the Llama, which weighs about 1 to 2 gigabytes in size. Finally, on networking, we put the instance in a public subnet with an internet gateway and a security group that opens port 22 for secure shell and port 3000 for our web UI. This configuration delivers low latency, inference, and a smooth chat experience, all on a single cost-efficient GPU instance. This is our proof of concept demo for our Ollama AWS setup. First, I'll start by logging into AWS console and completing the MFA authentication as required. On the access port, I'll select the project account that we created for this class. In the console, I'll select the BPC services. That's where we're going to create our networking resources. Now that I'm in the BPC dashboard, I'll create BPC. We'll choose the option to create multiple networking resources. I'll give the BPC a name of CIS3050 Ollama. I'll leave the default CIDR block to a /16. I'll stick with a single availability zone and provision both a public and private subnet. Next, I'll add a NAT gateway in the public subnet. Here you can see a network flow preview that shows a public and private subnets, internet gateway, and route tables all linked together. Create the BPC. Our BPC creation workflow spins up as it's being provisioned. AWS setting this up in the background, just making the setup much straightforward. Once complete, I'll verify the BPC is present and all its networking resources. I'll check the elastic IP allocated to us is there as well, and the NAT gateway for Android translation is also there. Next, we'll set up our security group that will function as a simple stateless firewall. I'll give it a name of CIS3850 Ollama, similar to our BPC. I'll give it a simple description about its purpose, which will be used to open up ports to access our Ollama instance, BSSH, and the OpenWebUI through our browser. We'll link it to our newly created BPC. I'll create two inbound rules. One for SSH, so we could remote access into our EC2 instance, and port 3000, which will allow us to access the OpenWebUI through our web browser. I'll hit create security group. With that done, I confirm the security group appears correctly.
Here's a list of some of the commands that I'll be using to install Ollama, OpenWebUI, and Docker. In the next slide, we'll go ahead and actually use these commands in a live demonstration to show how it works.
Hi class, today we're going to install your own personal and private ChatGPT-like OpenAI model or any other small LLM on your own machine or on a AWS as a cloud provider. Then we will install Ollama, which facilitates the installation of running one of various small AI LLMs. In the case, we will install Llama3.2 /1B, which is only 1.3 gigabytes, or any other small LLMs later once we have whole setup running on a Docker container on AWS. And then after that, we plan to install OpenWebUI to create a front end that will look just like ChatGPT that you're used to, but it's going to be running on your own private AWS cloud provider. So now my partner Jason will take over and actually walk us through the steps of doing this. Go ahead, Jason.
Thank you, Ed. So here we're going to go into our AWS instance here. We're in EC2. We're going to go into the instances and launch an instance. So we'll click on that. And then here we're going to go ahead and name our instance, which is going to be our virtual machine. So we'll name it Llama Final. And then next we're going to go ahead and select our operating system. We're going to be looking for this deep learning base of the NVIDIA driver GPU AMI. And we're going to select that one. Next, we're going to confirm the changes, and then we're going to go down to the instance type. This is where we'll be selecting, which CPU and whatnot that are going to be on the system for the virtual machine for our instance here. So here we're going to type in G4DN X large, which is the one we want to get with the full CPU cores and 16 gigabytes of memory and the NVIDIA driver. Next, you can go ahead. We're going to go ahead and change the network, but here sometimes you might run into issues if you had a pre-configured network, so you may want to leave it as default. But here we're going to go ahead and change it to the one that we have selected here. And then next, security groups here. Again, you may have one that's been pre-created, right? But we're going to go ahead and just create this new security group. And then for the storage, we're going to configure 275 gigs of storage, and then that's the minimum for these for this specific instance type. So we're going to leave it at 75. You could configure it, but we're going to go and launch the instance. And here, depending on if you want to have access to SSH from a remote machine, you can go ahead and either use an existing pair, a key pair, or create a new key pair. But for now, we're going to go and just continue, proceed without the key pair. Then launch the instance. And we'll give it a second here. So great, here now we see it says successful. So we're going to go ahead and click into the instance here, the ID. And next we're going to click on connect, which here you'll see we have the option to connect using the EC2 instance connect, which is just connecting via web browser. And we're going to be SSHing into the device to get started with the device. So we're going to update the Linux instance using the command. Once it has verified all the updates that it's listed, we're going to go ahead and paste another command in to actually update the device once it's checked it. So here we see it's done, and then we're going to actually paste the command to update the device using upgrade. Okay, so next we're going to go and proceed to the next steps to install our Docker and Ollama. So here we're installing Docker by using this command to get some of the source files from the Docker repository. I'm going to be adding some of the apt sources.
Yeah, well, this is working, guys. These commands are going to be listed on the back of the PowerPoint as a linked TXT file with all the commands. If you guys want to play with this at home on your own time, I highly recommend it.
So here we're going to paste this command to run Docker. Here we see it's actually active and running. Next, we're going to go back into our EC2 instance here, and we're going to go back into the security section and open up a port so that we can actually connect into our OpenWebUI. So we're going to edit the inbound rules here and add a new rule with custom TCP with the port range of 3000, which is what OpenWebUI is going to be using, and then allow for anywhere IPv4. Save the change here, and then now we see that we have SSH and then that custom port open. So now here, we're going to go ahead and go into installing Ollama onto our Docker.
And we're also going to be at the same time here installing OpenWebUI, which is going to be the front end, all in a single shot. So that command does both the Ollama installation and the OpenWebUI, as you can see there in the command line.
Right, so now that's completed, we're going to go ahead and go back to our instance and grab the public IP address from the network interface and put it into our browser with port 3000 at the end to interface with OpenWebUI. Here we're going to go and create our account here. We're going to put your name, email address, and password in here as the admin account so we can get started on OpenWebUI here. Interface, it kind of looks like ChatGPT, right? So now we need to insert a model. So here we're going to select the model. We're going to be using Llama3.2 1B. So generally what you can do is you can just copy and paste this into the model. Generally if you're doing it through the command line, you can go and copy and paste the command that's in the actual Llama website. So here, right there, as you see, that's the one you would copy into your Linux instance. But yeah, this one's going to be downloading the model here now. So once it's finished and verified the integrity, you can go and select that model here, and then go and just chat the bot. I'm going to type hi in here, and then we'll see here that the bot responds back. So hi, how can I help you today? So that's the bot responding to the chat that we created. And here you can see there's an admin portal if you wanted to add other users here. So I'm going to add Ed here, just to verify that he can access it through his computer.
Yeah, so basically, guys, once you add users, it's just like OpenAI or Cloud AI or Gemini. You have access to it from anywhere on a browser, from any computer, anywhere. Just imagine what you could do with this ability, right? You make your own AIs. That's just super powerful in the upcoming future. But he's actually logged in as me, but I can actually log in from my end because we're on Teams. And the cool thing is that you could choose any model. You could choose various small LLMs, or depending on how big your machine is, and have a list of different AIs to choose from when you're logged into WebUI.
So here I'm just making sure that Ed is an admin user. As you see, a regular user didn't have the ability to add the language model like I did. So I'm just making sure that Ed is an admin so that he can go ahead and add like a language model. So if you want to use a different model, you'd have the ability to do so. I'm just verifying that the account works because when the credential you give out to your user actually works before they can actually use it. So here we see it's logging in, and we can verify it's logged in here. And here we're just testing to make sure that it works on the case account. So here we're just going to cut into where we're going to install DeepSeek. So we're back on the Llama website. Again, we're looking for the right model, so we're going to go copy that model, and then again we're going to put in the search bar a specific DeepSeek model that we're going to want to use. And then here we see it's downloading the model onto the actual OpenWebUI in here. It's verifying the SHA-256 digest, just to make sure that's the correct file that was downloaded. And here we see, now we can see DeepSeek, and we're going to go and just type to DeepSeek to make sure it's working here. And you see here it's thinking.
So DeepSeek has a reasoning model. It'll sit there and think and show you how it's thinking before it actually replies. So it's a little bit different than your Llama 3.0. So right there it's saying, all right, let me figure out how to respond here. It's saying, should I consider, make the response more helpful? And then it finally figures out the solution and it says, oh, I know what I'm going to say, and it answers to you. So yeah. So pretty cool, guys. This is how you make your own AI. So pretty powerful. I think that everybody needs to know how to do this because the future is going to be AI. Thank you for your time. I really appreciate you guys. Thank you.
Here's a list of all of our references for our presentation.